OK, so in this example, ladies and gentlemen, we're trying to find y prime. And the first portion here, that's fairly simple, right? That's just really using the formula for the derivative of inverse sine. So that's going to be 1 over the square root of 1 minus x squared, right? Basically, just as we have there. We don't have a differential function inside of the x. So it's just example of that. And then plus one of these again, right? So again, we look at this and we see, product rule, product rule. This times this. So by applying the product rule, we could take the derivative of the first term, which is going to be 1, times the square root of 1 minus x squared, plus x. And then we notice here, if I'm going to take the derivative here, I have to go ahead and use the Red Wings. Nice shirt. I like that. Good job. Really good job. Who am I delivering? OK, Alex. I'll get that to you in a second. So therefore, so now I have x, and then I'm going to multiply this times the derivative. So you guys got to think chain rule. This can really be rewritten to the 1/2 power. So I'd bring the 1/2 down, right? Times the inside. Subtract 1/2 times the derivative of the inside, negative 2x. Is everybody OK with that chain rule that I did quickly in my head? At this point in this game, we should be comfortable with it. But if you missed a step that I did, just let me know. And I'll be more than happy to kind of re-explain it. That's times. Use parentheses. Did you guys see that? I forgot to write a parentheses. Do you guys see how big a mistake that was if I didn't put parentheses in there? I looked at that, and I'm like, minus 2x, where's minus 2x come from, right? But if you're like taking a test and you're and you're like, going through things, you're going to like, you'll have that, you won't even catch it. Make sure you guys remember your parentheses. That's multiplied. That's huge difference. All right. So let's go ahead and rewrite everything. And let's kind of like clean some things up here. So we can think of this as being in the numerator, squared. And then plus over here, we got a couple things in the numerator, a couple things in the denominator. So it looks like the 2, I have a 2 in the denominator, 2 in the numerator. So those divide out. And it looks like I'm going to have a negative x squared all over. We could rewrite this back as a square root of 1 minus x squared. And I can put that over 1. Right? Everybody see? So all I really need to do, guys, if I want to get them to be like term or to combine them, all I really need to do, these already have common denominators, right? The only one that doesn't have a common denominator is this one. So all I really need to do is just multiply this times the LCD, which is square root of 1 minus x squared. Then, once I do that, I have y prime equals 1 over the square root of 1 minus x squared. Plus, notice here, if the radicals are now going to, right, square root of 1 minus x squared times the square root of 1 minus x squared is just going to be 1 minus x squared. Follow? And what am I, x squared? Yeah? Where? Here?
No, like the
Here?
negative x squared over. Isn't this supposed to be just negative x?
Well, this is times x, and then it's the derivative chain rule gives me negative 2x. So then I had x times x. That's how I got the x squared there. But I'm trying to see. That gave me the x squared, and that gives me the x. I'm trying to see. Yeah, it should be minus the 2x. OK, I guess I just wrote that down wrong. So now, though, guys, we have all like terms, right? And all we got to do is combine these two and those two, right? So y prime is equal to 1 plus 1, which is 2. Negative x squared minus negative x squared is negative 2x squared, all over 1 minus x squared. Okay? So again, guys, the reason why I bring a lot of this up is, the hard part about this is it's not the rule.